Hello, today we're going to talk about section 15B, which is calculating probabilities of normal distributions. So the first thing we need to look at is our standard 68, 95, 99 rule of normal distributions. So essentially what this is telling us is if we have a normal distribution curve, 68% of the data, roughly 68.26 to be exact, percent of the data falls within one standard deviation of the mean. So if you guys remember, our mean is in the center, right there where I highlighted it. And so you can see that one standard deviation above and below the mean, that's going to be 68% of your data. Now, the 95%, what it's saying is that 95% of your data is going to fall within two standard deviations of your mean. So from two standard deviations above and below. So anywhere in here, this is 95% of your data. And then the last one is your 99, and 99% of our data is going to fall within three standard deviations of our mean, roughly 99%. So you can see that all of your data is going to be within that three standard deviations. So let's do a problem and identify all of our parts as we work through our problem. Okay, so it says a sample of cans of peaches was taken from a warehouse and the contents of each can were weighed, and the mean of it was 486 grams and the standard deviation was 6 grams. So we want to state the proportion of the cans that weighs between 480 and 486. Well, for you visual learners, let's draw out our normal distribution curve for this problem. So I'm going to just go to a different page here. If you remember, we have a horizontal asymptote, and then we have our normal curve. Our mean is in the middle, which is going to be 486. And then remember, we want to talk 1, 2, 3 standard deviations above, and 1, 2, 3 standard deviations below. So using our standard deviation of 6, we are going to add 6 to each from a 486 to get our first one. So that's going to be at 492, and then add 6 more and you're at 498, and add 6 more and you're at 504. And then going the other direction, if we subtract 6, we're at 480. Subtract 6 more and you're at 474, and then 6 more and you're at 468. So here is our normal distribution for this particular curve. So let's go back to our problem for a second, and it says between 480 and 486. So if you go here, we're talking about this chunk right here. So when you go back to that normal distribution curve, that's going to be this part right here. So that means that there's going to be 34.13% of that data is falling between 480 and 486. So you guys you're going to want to get familiar with this curve here because that's going to be, for right now, how we're going to calculate those probabilities. Okay, so let's go and read the next one. It's asking us, part B says, more than 492. So if we go to our diagram here, we want more than 492. So now we're talking about this whole part. So everything above one standard deviation, that's above the mean. So then if you go back to here, we're talking about this part right here, which means what you're going to want to do is you're going to want to add these three probabilities together to be able to answer that problem. So if we have, let's see here. So this is going to be 13.59 plus 2.15 plus 0.13, which is really going to be 13.59 plus 2.15 plus 0.13, which is 13.59 plus 2.28. So if we add, 28. So 15.87% is going to be more than 492. And then, do we have any more? Nope, that's it for that one. So all we're doing is we're looking at where we are on that normal distribution curve and adding those percentages together. So let's look at another problem. Okay, so the chest measurements of 18-year-old footballers are normally distributed. So this is key, it's normally distributed. We have a mean of 95 and a standard deviation of 8. So the first thing we want to do is draw our bell curve. So here's our curve. Our mean is 95. And then we go 1, 2, and 3 standard deviations above and 1, 2, 3 standard deviations below. And we're using that standard deviation of 8. So when we add 8, we have 103, and then 111, and then 119. And then when we subtract it, we're at 87, 79, and 71. Okay, so find the measurement or the percentage of football players with chest measurements between 87 centimeters and 103. So 87 to 103 is this middle area. And so if we go back to our original bell curve, that middle area is going to be these two right here. So you're adding 34.13 plus 34.13, and you are going to get 68.26. Okay, the next one says between 103 and 111. So now you're looking at this area of your curve. So if we go back to our bell curve, let's erase this stuff. So we're talking about, let's see here. Oh, I did that wrong, sorry. It's not that, it's just that one right there, which means it's your 13.59%. Okay, now it says find the probability that the chest measurement of a randomly chosen footballer is between 87 and 111. So notice, you guys, I'm wording it a little differently, but I'm asking you the exact same thing. So when you think about what is that area under the curve, we'll just go with the green area. So we're going from 87 to 111. So now I'm talking about this entire area here. So we're really adding these two together because that's the area that we are getting. And when we add those two together, when we have the 68.26 plus 13.59, we get 81.85%. So that means 81.85% of the time you're going to get a randomly chosen football player that falls between that 87 and 111.